I'm from Zambia, and I'm a senior lecturer at the University of Zambia, and also a legume breeder. So to start off my presentation, I want all of us to kind of remind ourselves in terms of the global challenge that we face with regard to the increasing global population. And I want to focus on Africa, where I'm coming from. This global challenge of feeding the increasing population is more dire in Africa, and essentially because of the gap that is existing and keeps on growing, and that gap between the population growth and the amount of food that we are producing. The two don't match up. And this has resulted in excessive malnutrition in some of parts of Africa. And you could see, if you look at the map there, and you could see the coloration, it's most of the affected countries in terms of food insecurity are going to be in sub-Saharan Africa. And but why is that the case? It's because we have very weak governance systems, and those systems are just not geared up to cope up with things such as climate change and the things that result from there, such as drought and floods. All these have had a very devastating impact on our farmers and on our food security. So there is urgent need for us in Africa, particularly in sub-Saharan Africa, really to increase on the amount of food we are producing. But not only in terms of the area we are growing, but also to increase on the productivity, how much we're able to produce per unit area. And there are several approaches that we can use in terms of resolving that. But I strongly feel that plant breeding has a special role to play in that. I want to focus on Zambia just to give you a sense of where I'm coming from. As Zambia, we depend a lot on agriculture, and over 70% of our population depend on agriculture. And it's a source of food security and also income for a lot of our people. We are about close to 20 million people in Zambia, and most of our farming system is small-scale farming system. And these are small-scale farmers who have got, in most cases, less than 2 hectares where they are growing food for their own food security and also for selling part of that to be able to meet their household requirements. This just is to emphasize the important role agriculture plays in our economy, but also in the socio-economic status of our people. The breeding program that I had here at the University of Zambia is geared towards addressing some of the major challenges that our farmers face. And most of my clients are actually the small-scale farmers. And if you picture these people, for you to give you a better sense of what we are talking about, these are farmers who are food insecure and with very little income that they make per year, and they depend a lot on agriculture for their sustenance. And some of the the demographic groups that participate in that include the women and also the youth. If you are talking of the legumes here in sub-Saharan Africa, particularly in Southern Africa and also East Africa, women play an important role in the production of legumes. And why the legumes? It's because of a number of reasons. One, they are nutritious, and secondly, they are easier to grow compared with other crops such as the cereals. And when I'm making this comparison, I'm looking specifically at corn, which requires a lot more fertilizer and a lot more other production inputs for you able to produce them. And those are not affordable to most of our small-scale farmers. And that's the more reason that these legumes are more desirable to them. However, despite the socioeconomic importance of these legumes, the farmers face myriad of challenges, including the poor soils. Our soils are very deficient in phosphorus, in nitrogen, and whatnot. And this makes it very difficult for them to be able to achieve the yields that they need for them to have the food security and the income that they need. And these are some of the problems that I try to address in the breeding program that I had here at the University of Zambia. So the breeding program is focused on 3 commodities. We look at cowpeas, soybean, and dry beans. And there I present a list of the breeding objectives or the traits that we are interested in. But you could see that in all the 3 commodities, we are interested in disease resistance. We are interested also in abiotic stress, particularly drought tolerance. This year, Zambia had one of the most severe droughts we've ever had in the last 50 years. And we lost almost half of all the production area of our crops. And that's serious because then it means we are likely to have very severe food insecurity. And but this drought reminds of us in terms of the need for us to make even major investments into breeding programs because they can play an important role in terms of addressing these challenges such as drought, which are exacerbated by climate change. So you could see there the whole shopping list of what I do and of the challenges that I face in terms of trying to address all these traits. Some of them are very complex to deal with from a genetics point of view, others not so much. You should be able to address them fairly well because they are not genetically complex. But all these, once they are addressed or are able to address some of them, they're important in addressing the food security and hopefully improve the farmers' livelihoods. How are we able to address those long, shopping list of the traits that we are interested in? The one I've shown you. It all goes to plant breeding 101, the basics. We have large-scale trials that we set up. And because breeding is a numbers game, for you to be able to get anything useful from your trials, you need to have as many materials as possible. And we are trialing in quite a number of locations within Zambia, but also in the region in other countries that we collaborate with, particularly in Southern Africa. The idea is that hopefully we can get some of those materials that have the tolerance to these abiotic and biotic stresses that we experience. At the bottom of the 2 pictures that I'm showing there is a drought experiment. We do quite a lot of trialing on drought and to try and identify varieties that have drought tolerance, and that could help us, cope up with the effects of climate change, including drought that we are experiencing. So now I want to go into some specifics in terms of the achievements we've had as a breeding program and our impact. We've managed to develop common bean varieties that are resistant to major diseases that we have here in Southern Africa, including Zambia. So one of the major diseases that we have on beans, and beans is a very important crop, a major source of protein, and also zinc and iron for us here. Quite a number of our people cannot afford meat, and therefore beans present a cheaper alternative source of protein, zinc, and iron. But the productivity of beans is very low. You can think of less than a ton compared to the potential or the yields that they are getting in West countries, which are as high as 2 tons per hectare. And one of the things that contribute to that low productivity are the diseases. And the major one is anthracnose. It's a major disease for us here in Africa. What my breeding program has managed to do, we've managed now to introduce disease resistance in most of our varieties here in Zambia. And we've been able to do this within a period of actually about 5 years. And now have we been successful? It's because we've used marker-assisted breeding to be able to help us achieve that with the support of our partners, who are a number of them. And there I'm just showing you in terms of the breeding procedure of what we've been able to do. And you could see one of these materials where we don't have resistance gene in terms of the way the plants are killed. It completely lost that crop, and where we put now the resistance gene, how clean they are. And the same applies to another major disease called common bacterial blight. And what we've managed to do is to be able now to develop this Kablangeti variety, which is very popular here in Zambia. But until our intervention or the intervention of my breeding program, this is a variety that was highly susceptible and farmers were facing serious low productivity. But a simple solution of putting in a couple of genes there has managed to address that low productivity, delivering to the farmers a higher yielding variety that is resistant to these two major diseases, anthracnose and common bacterial blight. That just goes to showcase in terms of the special role that plant breeding can actually play, particularly in Africa, to improve productivity. What you're seeing there is again our breeding for drought tolerance. We've been using quite a lot of basic studies for us to be able to for us to be able to understand, the genetics of drought tolerance of some of the materials that we have here. And we've been using some of our new phenotyping tools, phenotyping for all sorts of traits, including enhanced photosynthesis. And what we do now is to be able to apply that basic knowledge which we gain from all these techniques, such as genome-wide association studies, QTO analysis study, and use them in our breeding methods, for us to be able to develop varieties that are tolerant to drought stress. And some of those pictures, like you could see, is just some of the trials that we conduct depicting the stress and non-stress conditions for drought. And we've been able to identify materials of common bean and also cowpea that are drought tolerant and will give you better yield and severe drought conditions. And this has been quite a major achievement on our part. And how have we been able to do this? Combining conventional breeding methods, strategies, but also backing them up with, the use of molecular genetics and new tools in genomics. One of the things that we've been also working on is to try and address the issue of malnutrition. And malnutrition, that one that results from deficiency in iron and zinc, which is the hidden hunger, as we refer to it here in my country. Unlike in the Western countries where they can where they can fortify the food and fortify themselves out of the deficiency of iron and zinc. For us here, we don't have that privilege. Most of our communities tend to experience quite severe iron and zinc deficiency. But we realize that common bean is one of the crops that is very rich in iron and zinc. And we've been trying to use it as a vehicle for us to deliver this iron and zinc to our communities that don't have access to fortified food. But the challenge that exists with common bean or dry beans is the longer cooking time. And sometimes that just doesn't, incentivize consumers to increase on the consumption of common bean. So what my breeding program has done, it's been able to develop common bean varieties that are faster cooking, that also have high iron and zinc. But we are not only looking at high iron and zinc or the concentration levels, but we are also interested in the iron bioavailability, how much of that iron actually ends up in the body. And we've seen that we have a lot of genetic variability in all these traits. And what we've been able to do with my research group is for us to be able to take advantage of that genetic variability and develop varieties that are faster cooking, high iron concentration, but also high iron bioavailability. And what I'm showing you there are two of the varieties that we've managed to develop and we have released to the farmers. The one on my right-hand side, on your top right corner, is a Lusaka bean, yellow bean, which is liked by consumers a lot. And this is a variety now that is faster cooking with high iron and zinc. And on the left-hand side is a new variety we released last year, Again, high iron content, very fast cooking, and very desirable. And this fast cooking is important because then it helps us to address the issue of deforestation. Most of our communities use charcoal for their cooking as cooking energy. And when you're having these beans that are taking so long to cook, they just contribute or exacerbate this issue of deforestation. Another trait that my breeding program we've been successful working on is breeding for common bean weevil resistance.
Would you mind to finish in 1 minute? Thank you.
All right, sure. So we have the common bean weevil, which is a major post-harvest trait for us. It does a lot of damage to our seed. And again, my breeding program has managed to develop varieties that are resistant to this and help us address the post-harvest challenges that we face. And there I'm showing some of the varieties that we've been able to develop that are resistant to the common bean weevil. Mutational breeding is one of the techniques that we've used quite extensively in my breeding program and also in Zambia. And here we are showing the work that we are currently undertaking with the support of IAEA. We have irradiated those two varieties and developed over 15,000 of these mutants. We are currently screening them to identify varieties that are resistant to Maruca. Maruca is a major base for us here in Africa. In West Africa, there is a genetic engineering solution to that. But here in southern part of Africa, we're not so much interested in GMOs, genetically modified organisms. And that's why mutational breeding presents an opportunity for us to develop that variability that we need. Through mutational breeding, we've been successful to release some new varieties. Here we are showing our two new varieties, Lunkwanko and Lukusus, which were released by my colleague who I work with. And these are the varieties that are really going to make an impact because our currently grown varieties are more than 20 years old. And these are the new varieties that are high yielding and also resistant to quite a number of biotic and abiotic stresses. Eventually, we deliver these materials to our small-scale farmers. I'm just giving you a sense of our seed system. We get these materials to some of the most vulnerable, but these people are excited to have these new varieties because that gives them a hope to improve food security, particularly the women who are mainly involved in this production of legumes. With that, there are several organizations that are involved in supporting our work, and those ones I present them in there. So thank you very much for this opportunity to share with you what we are doing and the role of mutational breeding in addressing our food insecurity. Thank you.